This video will take us through the workflow of our plan to allow anyone to learn LabVIEW anywhere. And it starts off with VirtualBox. So you download VirtualBox, make sure it's the latest version, presuming the host of the training is going to have Windows, so I won't go through the install, but it's a standard Windows install. Then it downloads, and then from VirtualBox, what I really want to do is to download a virtual machine which is already set up. So I pause the video just to give me more time to talk about this. So the virtual machine will be Linux. All of these things are chosen because they're license free. This allows us to install and use tools that are license free, giving us a free platform to do the training on. So my aspiration, and I've been talking to G Central, is that this comes through G Central. We get a place on their site which is for training. So this is completely and utterly simulated, this screen, but the idea is that you download your OVA from here. An OVA is a transportable virtual machine. It's big, it's 7 gig. But even that in say India, for example, is only a 12-minute download. So it's for the average across India. So it's not as big a problem as you would think. And then you would all separately download the course materials. Again, all open source, all free. Ideally, the trainers will be pushing it back, but I'll show how that goes now. So you can see that's just downloaded. So this is just the next step: is you open VirtualBox and you import an appliance. So I'm just checking here to make sure that's the right version. So version 7 it has to be. So here you just go. And then this is in Windows currently. So you go to download and import it. This is dramatically sped up, or it will be when it starts installing. And this will be installed with LabVIEW installed too. So LabVIEW for Linux, but not activated. So to activate it, there's a lot of Linuxisms here. To get it to activate properly, the easiest thing is open Firefox first, launch LabVIEW, activate it, Community Edition, and you type in your email and password. And then it tells you you've been authenticated and it opens as per normal. So that's nice. Kill that off. So now we've modified this. Let's reload it again. So we modified this. We've modified the XML so that you can download directly from GitHub on the first screen as an XML file in the LabVIEW install. That allows you to do that. So you just download a zip file of the course materials. So again, you should be able to select from the course materials. This is using GitHub. So encourages people to join in and make modifications and branches and all of that. So it's a proper open source way of dealing with it. So here I'm just extracting it onto my desktop. You can see there, getting started is on the desktop, and there's the standard sort of course. So every piece of hardware will have an emulator. Again, standard LabVIEW, the source code will be provided so people can make their own. So I'm just running it. This is how currently the easiest way I know how to run an executable, a built executable in Linux. So here, just select the subnet, and now you're running, and this is a Visa emulator, and it's emulating the hardware we're proposing using, which is based on a Pico currently. So if we open the course materials again, these are just a sample course materials that I've knocked up. This is a standard doing a hello world. So the manual just takes you through how to get everything going. So we just load LabVIEW, create a new VI. And then set it up as per the manual. So my idea for a hands-on is you actually get people building it. They're not actually really explaining a great deal at this point. You'll see me in this. It's been edited out. You'll see me struggle with minimizing LibreOffice. You can see here it's just going through the manual, and here we're dragging and dropping from the instrument library the hands-on material. So here these are the drivers that will talk to the hands-on emulator or the hardware. So the option is that the manuals can be printed, so not skipping back and forward like this. But the idea really is that we always keep it as free as possible, shall we say. This is me struggling with the minimize and maximize and weirdness of of LibreOffice. It's very annoying. I'm sure. There we go. Finally. Right, so now LibreOffice is to the side, so we can actually do some programming. So here I'm using Quick Drop just to auto wire, and I'll go through actually wiring the thing up. So this is a standard sort of hello world example that you would do in a LabVIEW course, is just getting the hardware to do something. But I'm sort of trying to go through in the sort of course materials, which will get formatted, done properly at some point. Is, you know, you run it, you get an error. What does that mean? So the next easy one is you just copy the Visa resource name address. Resource name there, and now if you run it, it'll work. Put the execution highlight on because that's cool, and then you see there the LED is turned on. So this is the example of how the course goes together. If we now set up a shared folder, and now we're going to have a quick look at how we would load the microDAC image onto a Pico, just in case you're wanting to do some hardware-y stuff with actual hardware. So this is always the plan, is if the host of the training can afford it, then at sort of $20, $25 a head, you can actually use some hardware as well. So this is me just setting up a shared directory and dragging the downloaded file over. There's probably easier ways to do it, but Linux. So we're going back to the desktop to find the downloaded directory that we got from the training. Go in there, we'll find the firmware directory, and the firmware directory will hold our microDAC UF2 file, which is what you drop it onto the Pico. So what I'm doing is dropping that into the shared directory, because we can go back to Windows then. So this is something the host would prepare beforehand, really, but it shows you the complete way it works. So back on the host machine, if we just open up our shared directory, you see we've got our UF2 file there, and then we'll load the hardware. So this is just a Pico, a WIZnet Pico, and it's got an Ethernet port on it as well. You can just see here's the installing the hardware, firmware. The firmware. So you press boot select, you plug it in, it comes up as a little hard drive, and when you drop the UF2 into that hard drive, it's for new firmware. It's as easy as that. Pop, and you see that all it's doing is blinking a little LED, because we haven't finished writing the microDAC software yet. Derek Bomrito is currently busy doing that, and yeah, and that's the workflow really. That's everything we're thinking about with regard to getting LabVIEW into people's hands anywhere with whoever wants to do it.